Science and math has taken on a whole new meaning in our everyday lives. Society is learning to embrace technology and engineering. Society has coined the term STEM to include science, technology, engineering, and mathematics. But what does STEM mean to us? How can we use it in our everyday lives? STEM starts with science, and science is about discovery. Science is about observing closely at how our universe works and discovering the interaction of the world around us. Through science, we can understand everything from fire. What is it made of? How do you create it? How can you use it to make your life easier? All the way to quantum mechanics. What is too small to see? How does it behave? What does it mean for us? Science is about discovering how to define things. We use Kelvin to define temperature, kilograms to define mass, and meters to define length. But what is a meter? It is a unit of measurement, but how long is a meter? We use measurements every day. How far is it to my friend's house? How much baking powder in this recipe? How much electrical potential does this battery have? But where do these measurements come from? Science. The meter has been used for centuries and often was used for determining taxes and trade. But how can you be sure all countries are using the same measurement? Well, it has been through many variations. Today's definition of a meter is the length of the path traveled by light in a vacuum during a time interval of 1/299,792,458th of a second. With science, we are able to find a precise measurement that can be duplicated and used globally. Through science, we can also discover the different properties of materials that we can use for improving our everyday life. Where did X-rays come from? Madame Curie, the first woman to win the Nobel Prize, pioneered research on radioactivity. She also won another Nobel Prize with her work on isotopes, as she discovered two elements, polonium and radium. While a large part of science is discovering the properties and uses of everything around us, a significant part of science is determining the principles of things we cannot see. Through science, we have been able to manipulate sound, understand light, principles of motion, bonds of atoms, movements of planets, and growth of plants. And what about force? Science has allowed us to determine forces and shape them to work for us. By analyzing properties of materials, we have used steel to forge tools and weapons. Through observation, we come to understand the four forces in a rocket. thrust, gravity, lift, and drag. While the forces on a rocket seem simple, the motor produces thrust to push the rocket skyward, and gravitational forces pull the mass in the opposite direction. The other forces, lift and drag, are not so simple. Both are dependent on the speed of the rocket. It only becomes stable once it leaves the guide rod.
Main gear touchdown. Atlantis' nose being now rotated down toward the runway. The chute being deployed.
Drag works on the rocket to produce a stabilizing force on the fins, as do the forces of lift. It is only when the speed increases to the point where the center of gravity is forward of the center of pressure that the rocket will become stable in flight. The ancient Chinese were able to make firework rockets that reached over hundreds of feet in the air by observing that packing weight in the front of the rocket and putting fins in the back. Then they had a stable rocket. Science is about discovery. Only through observing can we examine properties and define them with mathematical equations or principles. While Isaac Newton discovered gravity in 1687, it was not until 1798 that Lord Henry Cavendish experimentally determined the universal gravitational constant. This allowed scientists to mathematically predict forces on planets in space. STEM includes math. Math and science work very closely together, but math is a tool to enhance our understanding and to communicate principles. One of our basic tools in math is numbers. Why do we have the decimal system and count to 10? Because math started with our 10 fingers. Our money systems are decimal with multiple denominations. Electronics uses a binary system with 0 and 1, or off and on. And computers with machine language use hexadecimal counting from 0 to F. The needs of math arose based on the wants of society. The more complex a society, the more complex the mathematical needs. Once society learned to count, we needed to do simple arithmetic. I will buy 12 kilograms of fish for $2.25 each, and I owe you how much? When society learned to live together, we needed to build bigger and better buildings. Early mathematicians learned to illustrate problems and solutions with geometric elements and develop mathematical tools to help build. These helped to build ancient constructions, like the pyramids of Egypt. This required geometry. Understanding and describing change is a common theme in the natural sciences, and calculus was developed as a tool to investigate it. Applied mathematics concerns itself with mathematical methods that are typically used in science, engineering, business, and industry. Thus, applied mathematics is a mathematical science with specialized knowledge. Applied mathematics focuses on the formulation, study, and use of mathematical models in science, engineering, and other areas of mathematical practice. Society has developed math in the areas of game development, fluid dynamics, numerical analysis, probability, statistics, optimization, telecommunications, cryptography, finance, physics, chemistry, controls, and biology. Sometimes it feels hard to define technology. It is changing day by day. However, we can never run out of examples of technology. Technology is developed out of our needs and wants for a better life. We wanted to live longer, healthier lives, so we developed better medicines and quicker access to care. We wanted to go to the moon, so we designed and built bigger rockets. Some of our society's best inventions came out of the need to communicate better and more effectively. The printing press, the telephone, television, the mobile phone, and eventually the internet. With every invention and enhancement of technology, we are aiding in the advancement of society. Because technology is driven by our human condition, it can also enhance our faults, like war. Technology is a sum of techniques, skills, methods, and processes used in the production of goods and services, or in the accomplishment of objectives such as scientific investigation, engineering design, or mathematical theorem. It is society's benchmark to gauge our advancement. With great societies, we can advance with great accomplishments like writing, the pyramids of Egypt, the steam engine, vaccines, electronics, and building the International Space Station. Technology is used to create better and more innovative education. Here at Roots to STEM, we are able to create an aerospace academy which can allow our junior engineers and astronauts the chance to explore life in the space program. Participants learn astronaut training, including flight training, mission control, survival training, and scuba training. Participants will also learn engineering with electronics, robotics, spacecraft design, high-altitude satellite launches, and rocketry. Technology has been through many different revolutions and stages. Some of the early technological developments would seem trivial to us today, like the development of the wheel and the invention of the axe. New technologies such as tools help us develop newer technologies and advance the greater knowledge of society. Technology is often a result of science and engineering. Although technology as a human pursuit leads to science and engineering. Science might study the flow of electrons and materials with electrical properties by using already existing tools and knowledge. This newfound knowledge or technology may then be used by engineers to develop new tools and machines such as semiconductors, computers, and other forms of advanced electronics. New math also leads to new technology. More recently, society has developed new telecommunication technologies, encryption technologies, control systems, and analysis. As a society, we must learn to better ourselves and the world around us. As our population grows, we need to learn to farm better without depleting the rich soil and destroying the environment.
Canadian dairy farmers are global leaders in sustainable farming, with a carbon footprint amongst the lowest in the world.
Caring for our planet, that's dairy farming forward.
Look for the Blue Cow logo.
Taking our current technology and building a better product or process is all about engineering. We learn to make better solutions for the needs of our society. So let us take a look at engineering. We left this one for last because it is the focal point of STEM for us at Roots to STEM. The application of science, math, and technology is engineering. Engineers use their knowledge of science, mathematics, logic, economics, and appropriate experience or tacit knowledge to find suitable solutions to a problem. Creating an appropriate mathematical model of a problem often allows engineers to analyze the problem and to test potential solutions. The engineering design process helps lay out the steps to help STEM students to work through a challenge and provide a useful solution. Engineering is the use of science, math, and technology to solve the problems of society. The main disciplines of engineering are chemical engineering, civil engineering, electrical engineering, and mechanical engineering, with new areas of aerospace engineering, marine engineering, and computer engineering. One of the most widely used design tools in the profession is computer-aided design or CAD software. It enables engineers to create 3D models, 2D drawings, and schematics of their designs. CAD, together with digital mock-up and computer-aided engineering software, allows engineers to create models of their designs that can be analyzed without having to make expensive and time-consuming physical prototypes. Engineers typically attempt to predict how well their designs will perform to their specifications prior to full-scale production. They use, among other things, prototypes, scale models, simulations, destructive tests, non-destructive tests, and stress tests. Testing ensures that products will perform as expected. In Canada, 3 important events help shape and bring our country together. The cross-country railway system, the microwave relay towers.
This is Alex Smith speaking from Toronto. This week, Canadian Scene is concerned with Communications Skyway, the miracle of microwave that's rapidly extending across the country by means of the Trans-Canada Microwave Radio Relay Network. Now, this is a project of the Trans-Canada Telephone System, a special organization of major Canadian telephone companies. With the line's completion, the public will be indirectly benefited by an increased efficiency in long-distance telephone service and, more dramatically, by near-instantaneous live television transmission by microwave.
And the Anik A satellite.
Anik, the Eskimo word for brother, is the name given Canada's satellite television system, which is expected to begin operation in 1973. Fed from ground stations in the south, Anik will provide live TV to the north, French TV west, and other forms of communication throughout the country.
STEM in our everyday life has evolved into a philosophy that includes collaboration, creative and systematic problem solving, confidence to work through the unknown, critical thinking, a growth of lifelong learning mindset, leadership and mentoring, role as a global citizen. Roots to STEM Engineering Academy is the North Star of STEM in Calgary, Canada. While we use math and science in our STEM programs, we focus on experiential learning with hands-on projects so students can immerse themselves in collaborative group projects and advanced individual challenges. Roots to STEM is an education center that weaves creativity and innovation through learning what are typically regarded as the tough subjects. Roots to STEM flexible and diverse programs inspire students to engage in STEM learning and to aspire to be future STEM leaders. The majority of our participants are aged 9 to 17 years old, but we have volunteers and mentors that support our initiatives. The programs lead to the development of vital 21st century workforce skills. Roots to STEM programs provided in the community and at our facility are focused on enhancing the STEM confidence level of every student, inspiring and preparing them to undertake future science and engineering level learning in high school and beyond. Roots to STEM has a 7,100 square foot campus to operate our STEM Engineering Academy.
Welcome to Roots to STEM. Glad you could join us. Come on in and have some fun.
The campus houses classrooms, an aerospace room, along with our lab of discovery, machine lab, electronics lab, and science lab. In our lab of discovery, students build projects that include robotics, programming, 3D design, and CNC machines. They learn to work with different materials and tools to complete STEM challenges and projects. The science lab has scientific test equipment along with hydroponic racks, nature aquarium, and geology section for a focus on the natural sciences. In our aerospace room, we provide instruction in flight training, aerospace engineering, spacecraft design, astronaut training, rocket science, and engineering. In our electronics lab, we look at building and integrating electrical and electronic components into our projects. Our Mars rover is one of our ongoing projects with support from our university interns at Roots to STEM. In the machine room, students work with advanced manufacturing equipment to provide a framework for bigger engineering projects. Our students build STEM skills through hands-on projects, challenges, and facilitation, ranging from lab and classroom instruction, individually chosen projects, collaborative group projects, discussions, and demonstrations. Roots to STEM is an engineering community where everyone comes to learn.